today I'm going to talk about big O notation. This is one of the most fundamental topics you have to know for a coding interview. So make sure to stick to the end of the video to get a good understanding of this topic. So you might be wondering, what is big O notation? Big O notation describes both time and space complexity. Time complexity is a measure of how efficient a program is based on the size of the input. This efficiency is represented by the number of operations that an algorithm performs. For a graphical representation, the x-axis is the size of the input and the y-axis is the number of operations. And this just shows a graph of all the different time complexities, but the three main ones I'm going to be talking about in this video are O of 1, O of n, and O of n squared. So that's pretty much the basic definition of time complexity. Space complexity, on the other hand, is a little bit different, but I'm going to be talking about that later in the video, so stick around for that. Okay, so the first time complexity I'm going to be talking about is O of n. So let's say that I have a array that just stores 5 numbers in it. 1, 2, 3, 4, 5. And then let's say that we want to add 5 to each number in this array. So it's going to look like 1 plus 5 is 6, 2 plus 5 is 7, 3 plus 5 is 8, but this is going to be the array we want, and the code for this is going to look like this. So the function, this is a function that takes in an input of an array called nums, and to add 5 to each number, we're going to use a for loop. This is a for loop, and we're using the I pointer to loop through the whole array using the length of the nums. And so to modify each number in this array, we can see over here, we're modifying the value at the value of at the index of I. So you can see, you know, in Python, to access a value of an array or of a list, you have to use these square brackets, and then you put in the index number, which in this case is going to be I. And we're going to be incrementing I each time. So this basically gets the current value over here and does plus 5 to it. And that's going to change the value of the list. So it's going to modify the value so that it's the current value plus 5. And we're doing this if let's say that the length of this nums array is n. This for loop is going to run n times because there's n number of elements in the array. So that's why this is just going to be O of n time. And that's our final time complexity. All right, the next time complexity I'm going to be talking about is O of 1. And this is the most efficient one because no matter how big the size of our input is, the number of operations performed is going to be constant. And let me show you an example. So I'm going to paste in the code. And this function just shows a function where it takes in an array called nums, and then it just adds 5 using this append method. So if we have an array, say 1, 2, 3, 4, and then if we pass in this function or this array into the function, then it's going to give us, it's just going to add 5 to the array. And this is O of 1 because no matter how big our array is, it could be as big as we want it, like that, it's still going to add 5 to the end of the array without reordering or rearranging any of these elements in the array. So we're not iterating through any of these numbers. We're simply just adding 5 to the end. So it doesn't matter. None of this stuff, none of the other values in the array, they don't affect how efficient it takes us to, or how efficient it is for us to add 5. So that's why this is, our final time complexity for this is O of 1. Alright, the final time complexity I'm going to be talking about is O of n squared. And if you're getting this time complexity in an interview, then you should probably find a better solution because there's probably a more efficient solution out there. So I'm going to give you an example and I'm going to explain why this is really inefficient. So this function gets an array and there's a nested for loop. And whenever you see a nested for loop, that's a good sign that's going to be O of n squared. Sometimes it's a nested for loop doesn't necessarily mean it's always going to be O of n squared, but a lot of times it is. And so it's going to, there's an outer loop and then the inner loop over here. And it's going to take in 1, 2, 3, 4. And the outer loop is going to go through each number in the array until we hit the end. And then the inner loop is going to go through each number in the array until we hit the end. And then once the inner loop is done, then we're going to go to the next number, and then we're going to repeat the same thing all over again with the inner loop. And you can already tell how this is going to be really inefficient because we're just checking the same numbers over and over again with this inner loop. And so that's just really inefficient because we could do this all in one pass. And so because we're checking the same numbers over and over again, there's going to be O of n squared time complexity. And the output is going to be a tuple. So the first value of the tuple is the value from the outer loop iterator or the outer loop pointer. And the second value in the tuple is the inner loop pointer. And so it's going to be 1, 1, 1, 2, 1, 3, 1, 4, and then the inner loop is done now, so it's going to go to the outer loop and increase the I value. So it's going to be n, or not n, 2, 1, 2, 2, 2, 3, and so on until we hit 4, 4. And the first tuple represents the value from the I pointer, and the second value in the tuple represents the value from the J pointer. And so this is a really inefficient solution, and there's a much faster way to do this, but I'm not going to be talking about this, the faster solution, because I already talked about O of n and O of 1 before this. Another important thing about big O is that if you have a big O, let's say of O of 2n, or if it's O of n squared plus 10n, whatever it is, we always want to drop the constants like this, or the non-dominant terms like this. So in this case, n squared is the more significant term. 10n isn't as significant because in time complexity, we're worried about how the efficiency changes over a large number or a large input size. And so this constant or this non-dominant term, that's going to be the impact of that on the efficiency is going to be negligible as we get to really large input sizes. So that's why this can be written as O of n, and this can just be written as O of n squared. Now that you learned about time complexity, I'm going to show you a problem where you can practice the big O concepts that you just learned. But before I do that, I'm going to quickly go over what space complexity is and also show you examples. I have an array of 1, 2, 3, 4, and I want to square each number. If I want to create a new array and square each number so that it's 1, 4, 9, and 16, then we're gonna have to create a new array, an empty array, and then add new values into that array. And so the code is gonna look like this. So this is the new array that we're creating, and this for loop is just looping through the nums, which in this case is 1, 2, 3, 4, and then it's gonna add the square of each number. So 1 times 1 is 1, 2 times 2 is 4, and so on. And it's gonna add that squared value into this new array. And so because our new array is storing, let's say our size of nums is n, because our new array is storing n numbers in its data structure, the space is going to be O of n. Now my question for you is, how would you change the space complexity so that it's O of 1 instead of O of n? And pause the video if you need to. So to change this space to O of 1, because right now what we're doing over here, creating a new array, it's kind of unnecessary for this case. So what we can do is we can directly modify the numbers of the array that we're passing in. And we just do like this. Takes fewer lines of code, and it saves a lot of memory. So basically we're using this loop variable I, and we're going through the length of nums, and then we're directly changing the value of nums by accessing the value at index I, and then we're gonna square the value. And so this is going to be O of 1, because we're not creating any additional data structures in this solution. We're directly modifying the elements in the input array. This is going to be O of 1 space, and again, the time in this case is going to be O of n, because we're looping through each value, or our index or our loop variable is looping through the whole length of the array. Alright, thank you guys so much for watching this video. I hope you found it helpful. I'm going to be discussing a lot about big O concepts in future videos, so stay tuned for that. And if you also want to watch a Python video that I uploaded recently, then click this button over here, and I hope to see you guys over there.